Hi guys, and welcome back. In this video, we will be looking at the concept of the gradient of a line segment. As I said, there is a difference between a line and a segment. A segment has a starting point and an end point, and really that's what we are studying here in analytical geometry. We're studying line segments. We're looking at different behaviors around them, what happens when they meet, what happens when they meet in a certain way, things like that. Okay, so far we have looked at the distance of a line segment. We know how to calculate that. We have looked at the midpoint, the middle point of a line segment, and in this video we are looking at the gradient of a line segment. A simple definition really of a gradient is to describe it as a rate of change. Okay, how fast does something change? If you are looking at this line here, straight line, okay, you're gonna look at as you move on, guys, as you move on into grade 11 and 12, you're gonna start, in fact, in grade 12, you will look thoroughly at the gradient of other equations or other geometric figures. Okay, for example, you're gonna look at gradients of things like parabola. You're gonna look at gradients of things like a cubic function when you're in grade 12. So that is why I'm using this definition to say gradient really is about the rate of change. Okay, so we've got actually each line here has a gradient, and I'm going to go straight into that. I'm going to tell you what the gradient of each line is. Now, I started by saying it is a rate of change, okay? In other words, change in terms of what? How one variable changes with respect to another. And we typically represent the gradient in as a ratio, in fact, yeah, we actually represent it as a ratio, okay? As a ratio of change, actually. Yeah, that's how you can look at it. So if I were to draw a straight line, a right angle triangle from this line here, okay, then the gradient actually, if you think about it, I had said it's change, okay, or in one variable and another. So there is a change here in y, okay, and there is a change here in x. And I said we describe that change as a ratio. So if I were to describe this change, gradient, we use the symbol m commonly in most cases. That's what we do. We use the symbol m, okay? So we will then say this thing is changing y over changing x. But what is change? Which between plus, minus, multiplication, and division. Okay, division already I've said is ratio, so we are done. We can't even think about this one. So between these three operations, which one represents change? I hope you said minus. Okay, yes, minus, subtraction, represents change. When you are saying 5 minus 3, you are saying what is the change? What is the difference when I take 3 from 5? If I take 3 balls from 5 balls, what is the change? What change have I made? What am I left with? Okay, so that's the idea. So that means here we are saying between point D and E, the gradient should be change in what happens vertically, and it divided by, since I said it's a ratio, by what happens horizontally. Okay, that should be an XE. You'll remember when I introduced the distance formula, I said it's very important to note that when you start with a D, you also start with a D on the other side, or on the other side, yeah, for lack of a better word, okay? And that's exactly what I meant. Of course, in the distance formula, it was immaterial because really we would always square this, but now it actually makes a whole difference. It matters, okay? So be very careful whenever you use this formula or write this formula down. that you are not going to say yd minus ye, then down here you say xe minus xd. You will get a wrong result. Be careful not to say ye minus yd, then you say xd minus xe. There must be a correspondence in how you write your coordinates, okay? So guys, let's check here. What is the change in y here? 1, 2, 3, okay? I think that's a 3. What is the change in x here? 1, 2, 3, 4, 5, isn't it? And I think that's it, okay? So that's what we have, all right? There's 5 there. And so that means the gradient here, so change in y or change in x should give us what? 3/5. So let's quickly prove that and see if the formula works. What is yd minus ye over xd minus xe? Y at d, okay, I didn't put down the coordinates for d. This is, so we're down here, x, and then y with this, so that you can follow through. This is 17 and 10. Then this is e, you can see here, it's 22 and 7. So I'm gonna go ahead and substitute here. The y value is 10, okay? And that is for D, and for E it is 7. For D, the Y value is 17, okay? And then what is the one for X? It is 22, all right? 10 minus 7 is 3. 17 minus 22, I think we can all see is minus 5. And so the gradient here is -3/5. So you can see this is the value that we get, and it is the value that we anticipated. Now, you are wondering, but you can't say that, what about that negative? This brings me to the next point about the gradient. A gradient has a sign, okay? In this case, this is negative to show that this is decreasing. It's a decreasing gradient, okay? Or we can say this is a decreasing slope. This one will be then positive to show that this is an increasing slope. In other words, let's go back to the definition. We said rate of change, meaning the rate of change here is decreasing. The rate of change here is increasing. That is just what the sign says. Okay, that's all. That's what you've got to know. The sign says the rate is either increasing or decreasing. So when the sign is negative, we know the rate is decreasing. When the sign is positive, we know the rate is increasing. Okay, guys, I'm gonna pause this video here, or stop it here for this part. In the next video, I will continue. And so remember, I said I try to keep this short, so I'll stop here and then we continue in the next video.